Hello, everyone, and thanks for joining us. On behalf of the Environmental Finance Center Network, I'd like to welcome you to today's webinar, How to Manage Grants. This is the second webinar that we've put together about the grant process, and I suggest checking out our Grants 101 webinar if you have not seen it yet. That's on our website, www.efcnetwork.org. Before we get started, I'm just going to go over some logistics and talk about our network. My name is Tess, and I'll be helping to facilitate today and do some questions with you later. So first, some logistics. During today's session, everyone will be kept on mute to ensure audio quality. If you have a question, just go ahead and type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving time for a Q&A at the end of the presentation, so feel free to send us questions throughout. If you are having technological difficulties, feel free to also use that box and I will do my best to help you. We will be making today's slides available as well as a video recording on the EFCN website. You can reach that website at www.efcnetwork.org, and just please give us about 2 weeks for the processing and posting of those materials. Here's a map of our registrants today. You can see we have about 270 people signed up to tune in today. As a registered attendee, you can receive a certificate of attendance for participating in this webinar. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credits. You will need to check with your licensing agency directly if you are interested in receiving educational credit. You must attend the entire 60-minute session by logging into GoToWebinar with your unique registration link in order to receive a certificate. And we will go ahead and email that certificate to you within 30 days of today's date. This session is one of several webinars conducted by the Environmental Finance Center Network for our Smart Management for Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local systems achieve and maintain compliance with the Safe Drinking Water Act. And here you can take a look at our Small Systems Program team. We have a national network with folks spread out in all 50 states, or across the nation rather, not all states. And here's some of our areas of expertise. You can see we focus a lot on asset management, rate setting, and fiscal planning, but also other types of water system management such as grants like you'll hear about today. We also have a Small Systems blog. Our blog posts feature lessons learned from our trainings and technical assistance, descriptions of available tools, and small system success stories. If you would like, we will give you the opportunity to subscribe to the blog at the end of the webinar. And one last resource that I want to point out to you before we really get going is our online funding sources map. This is a tool that can help you find the major sources of drinking water infrastructure projects for each state and territory. Here's how you access those tables. On the EFCN homepage, go to the Resources tab and then click Funding Sources by State. This will take you to a map of the country. If you click on the state that you're interested in, you will see a PDF table of the relevant funding sources for drinking water infrastructure for that state. The table looks like the image on the left of the slide. For each funding program, it includes the name, a short description, and contact information for someone that you can reach out to. And before we turn our presentation over to our experts for today, I just have some quick polling questions to get the ball rolling. So first, what kind of water or sewer utility do you operate? Just let us know if you have a for-profit system, local government, a not-for-profit, a different kind of utility like an authority, district, or school, or if you're not a drinking water system. I'm going to go ahead and give you just 3 more seconds to respond here, and I'm going to close this in 3, 2, and 1. Okay, and looking together at our polling results, it looks like the majority of folks joining us are 40% local government and municipal sources. So welcome, thanks for joining us today. And next, here's another question, especially geared towards water systems. Just tell us the size of your system. So we're interested to know if you're serving 500 or fewer people, or if you're serving, up to 10,000 or more. So take a look at those options there. Let us know where you fall, and then we'll be able to look together to see where everyone's coming from. Okay, I'm going to go ahead and close this in 3, 2, and 1. Okay, and Of our water systems today, the majority, or 17%, are serving 500 to 3,300 people. So that's really great to hear. We have a lot of small systems on the line. Okay, on that note, I'd like to introduce Heather Himmelberger. Heather is joining us from the University of New Mexico Southwest Environmental Finance Center. So Heather, you should be getting a screen invitation.
All right. We'll set up in just, all right. Now you should be seeing my screen, and I would like to welcome everybody today. So either good morning or good afternoon, depending on where you are in the country, and welcome to today's webinar, where we're going to talk about after you get the money. So this is part 2 of a 2-part series, and part 1, as Tess mentioned, was presented back November 8th of 2018, and that talked about how you go about writing grant applications, loan applications, how you develop the projects, and that sort of thing. Today is part 2. It's sort of after you get the money, and as Tess mentioned, you can view the recording of that webinar that was held on the Grant Writing 101, or part 1 of this series. It can be accessed on our efcnetwork.org website, and you can either look at the slides that were used during that presentation or actually listen to the recorded webinar, whatever works for you. Information that would go before this webinar today.
Hey Heather, I think we're having a little bit of a tough time hearing.
Have you seek funding for the whole test? Is there a problem?
Yeah, you know, it was kind of coming in and out for a second. I think it might have corrected itself.
Okay, well, let me know if that continues, and if so, then we can switch to the phone. So basically, the idea is that you can have some funding sources in which the funding itself will pay for the planning or design, and other times you have to do the planning and design first. So sometimes these activities occur before you get the funding, sometimes after. So the information might be relevant today for either part 1 or part 2. And one more item to note, we call this grants management, but it really applies equally to any kind of funding. It could be grants, it could be loans, it could be some other kind of funding. And it might, you know, we might use the word grant, but assume that it also applies to other things like, again, loans or bonds or whatever ways you fund your particular project. So the topics we're going to cover today that relate to after the funding is planning, working with your engineers, in particular alternatives evaluation and operations, looking at milestones, and we'll get into outcomes and outputs at that point, and then a little bit about finance. The 3 topics, planning, engineers, and milestones, are going to be heavier weighted on this particular webinar, but we will discuss a little tiny bit about finance. So let's start with the planning. So why does planning matter so much to us? Well, one of the biggest reasons is that if you look at the evolution of a project from the very beginning, when you're doing pre-planning and planning, to the end, when you're actually operating the facility, the ability to influence the project changes quite a bit from beginning to end, where you have major influence at the beginning, very little influence over the project at the end, and it costs you a whole lot more at the end than it does at the beginning. So when we're in our pre-planning or planning stage, which is the far left-hand side of the graph, it doesn't cost us very much to have a major influence on how the project will be carried out and what it will be like at the end. As we move into design, which is kind of that second box, our influence is going to go down somewhat and the cost is going to go up, but it's still relatively easy and inexpensive to make changes. By the time we get to construction, it will cost us a whole lot more and we'll have a lot less influence. And by the end, when we're actually operating our facility, the ability to influence anything at that point is quite limited, and it will be quite expensive to make any changes. So the greatest influence at the least cost is going to occur at those earlier stages, the planning and pre-planning stages. So let's look at a little example. So let's say the planner indicates the location of a storage tank, which is going to be on the hill behind the town. And then the engineer takes that planner's recommendation and designs the project with the tank in that location. The construction contractor takes the design and builds the tank on the hill behind the town. But then after the system takes over operation, the operator realizes that the tank location has two problems. The location is inaccessible in bad weather, so either rain or snow, and the elevation means that another tank overflows if you actually fill up the tank to the highest level. So at this point, if you want to actually do something about it, it's going to cost you a lot of money. If we would have addressed it earlier in the pre-planning stage, it would have cost us very little. And as we go along in the design stage and construction stage, the costs are going to go up. And by the time we get to the operation stage, it's the highest cost with the least ability to do something about it. So if, for example, at this stage, we wanted to say, well, let's put the tank somewhere else, that would be astronomically expensive to redesign the whole project, move the tank, and put it somewhere else. So that would really be prohibitive. So we'll have to figure out some other kind of workaround, and maybe we have to give up part of the storage capacity of the tank or something like that. So it will be a negative situation for us. So we want to have well-planned projects so that we can keep our overall costs low and have functioning projects after we're done and in operation. So we don't want to be left with situations where it might cause us a problem and that the facilities are not going to be functioning the way we want them to. So part of planning is understanding our initial starting place and the overall needs of our project. And then this will build into thinking about how the assets are going to be managed over time. So what are the operational activities that we have to do? What are the maintenance activities? What kind of repairs, replacement, rehabilitation options might occur over time with our projects? Asset management is one type of planning that can be very helpful with infrastructure projects. And we do quite a bit of work in the area of asset management, and we've had many webinars on this topic. So if you'd like to learn more information about asset management, please go to our efcnetwork.org website and look up asset management webinars, and you can find quite a bit of information. Just real quickly, we'll have a few slides to just give you an idea of what asset management is all about. And it has 5 core components, which start with identifying what assets you have, looking at how many, what type, the location, the condition, useful life remaining, and replacement cost. So this is where we inventory all of the assets that make up our system so we know what we have. The next step is looking at the level of service, or understanding what you want your assets to do and thinking about how well those assets are doing that. So are you meeting your customer expectations? You know, how well are you meeting them? The next part is figuring out which assets are critical within the overall inventory. So some assets are going to be way more important to you than others. And those are the assets that are most likely to fail and have very bad consequences if they do. So if you look at the high risk portion of this graph, the assets that are likely to fail, and it's really bad if they do, would be up here. Those would cause us considerable problems compared to assets down here that are unlikely to fail, and we don't really care if they do. This is where we want to focus our attention, and we want to make sure our projects actually include those critical assets, and that we're not replacing assets down here at the exclusion of assets up here, and then we'll end up not achieving the purposes that we would like. When we want to think about our assets over the entire life, we consider that life cycle costing, and that's the next component of asset management. This gets into thinking about when the best time to intervene in the life cycle of an asset, what types of interventions are possible, and the most efficient way to intervene so that we can have the best projects possible and really take care of our assets in the right way. The last component of asset management is considering long-term funding for overall sustainability of the system. So how much money do we need from day-to-day for our day-to-day expenses, and where is that money going to come from? So customers typically fund the day-to-day expenses of a utility, and then when you want to do your infrastructure projects over the life of the facility, as you're replacing assets, you have opportunities to get outside funding sources. You might be able to get grants and loans from various federal, state agencies that can fund infrastructure. And we do want to think about our projects over a longer lifespan. So not just looking at our assets today and maybe 5 years into the future, but maybe looking much longer, 50 to 100 years into the future. So what asset management activities are particularly helpful in the process of completing infrastructure projects? One is a good comprehensive map of your assets. This will help your designers quite a bit and your planners, because they'll have a better idea of where your assets are in the facility and in the community, so that you know what needs to be replaced and where. An asset inventory, so the listing of your assets and their characteristics, will help us again make sure that the project includes all of the assets that it should. A short and long-term capital improvement plan, so what do we need to do now and what do we need to do in the future? And then an understanding of the current O&M requirements. So what are we currently doing when we operate and maintain our facility? That helps us understand any changes that might happen in operation and maintenance, because the new facilities might be quite different from the old facilities. Another part of planning is the ability to ask yourself very important questions, and this is highly critical. So is this the right project? So when you contemplate what you're doing, really seriously think about the answer to the question, is this the right project, and is this the right time to do this project? So in the life of the community and all of the other things that are going on, is this the right time for us to do this project? What are the risks if I don't take this project on right now? What bad things might happen if I don't do it? And then what are the benefits if I do take on the project? So what is good, what is bad? And then thinking about, is this project being timed to correspond with something else, like road paving or growth in the community or a new business or something like that, so that we're thinking about, is the timing related to the timing of another activity? And if so, are we timing our project right to take advantage of that? So we really want to start to ask ourselves these very important questions, because remember, the best time to influence our projects is at the beginning as we're planning. So if it's not the right project or not the right time for the project, you really want to stop here and reevaluate whether it's worth going on. And even if you've actually already begun the process or received the money, initially, gotten word that you're going to get the money, it might not be the right project to continue. And I'll give you an example. This is a real world example that happened. This particular little community, a couple 100-person community, was looking at replacing all of its water pipelines. It was going to cost them $5 million to do the project. And it turned out that they were misconstruing what was going on. They were not having the number of breaks and problems that they thought they were. They really weren't basing the decision to go forward on the right information. When they reevaluated it with our help in having them do more of an asset management approach, it turned out that they could do a much less expensive project and ended up spending $50,000 to make a few strategic changes and had a better system at the end. So by doing a review of whether it was the right project at the right time, saved them $4,950,000, and they did not go forward with the funding, the $5 million worth of funding, and that was the right choice for them. So sometimes you really have to think deeply about, is it the right project? Is it the right time? And use that check to make sure that you're not spending money in the wrong place or at the wrong time or for the wrong project. If, however, you ask yourself those questions and you feel it is the right project at the right time, you're going to move on to design. So during design, you're working with engineers in most cases, and there's two main considerations for working with engineers that we'd like to cover today. This is not an all-exhaustive discussion regarding working with engineers, but just picking out two main aspects that relate to the situation at hand today. So one is looking at alternatives evaluation, and the other is blending operations into design. So in the alternatives evaluation process, this is where we're thinking about there are more than one way, there's usually more than one way to do a project. So there could be many different approaches that might achieve the goal you're after, and it's really a matter of which approach is best for you. So for example, if you have arsenic in your water and you're looking at different treatment options that might take the arsenic out, perhaps one of the options is to drill a new well. So you get rid of the well that had the arsenic and you drill a new one. Maybe another option is to join with a community nearby who doesn't have arsenic in the water. Maybe another option is to take two wells and blend them together, one that has low arsenic and one that has high. Maybe another option is a treatment system to treat arsenic, and maybe there's several versions of different kinds of treatment systems. So all of those will achieve the ultimate goal of removing the arsenic, but they'll do it in different ways. So it's important to think through each of those alternatives and make sure that the one selected is the one that's right for you. So some questions you can ask in this stage of alternatives evaluation is, are all the viable alternatives being considered? So is there an option that would be possible for you that is not being considered? If that is the case, then you need to go back and add that alternative in if they're not all being considered. Are they all being given equal consideration, or was one of the alternatives preordained either by you or by the engineer? Neither one of those cases is a good idea. You want to make sure that all the alternatives are given equal weight, because the one that you think might be the best alternative might not be. It's really important to keep an open mind. And another question is, are water system personnel able to suggest alternatives? And are their suggestions being given equal weight by the design engineer? So you might have some ideas of options that might be available that maybe the engineer hasn't thought of or wasn't aware of. And it's really important that your alternatives be given consideration. And maybe that isn't the alternative that will be chosen because it might not be the best case for your system, but at least it should be given consideration. Another question is, are the long-term costs of the alternatives taken into consideration or just the initial cost? This is hugely important. It is vitally important to not just think about the initial cost of doing the alternative. You have to think about what are the O&M expenses going forward. So you might have a lot of additional expenses that will come from whatever's being designed, and you need to know what those are over the life of the facility. So if, for example, the facility is expected to last 25 or 50 or 75 years, what are the costs going forward? So one alternative might have a higher initial cost, but a lower ongoing cost. And if that's the case, you want to make sure that you're thinking through that. So for example, going back to our example of the arsenic facility, perhaps one of the options is running a pipe between two wells so you can blend them together. Maybe the cost of that initial construction of the pipe is higher than the cost of a treatment facility, but if you look at the ongoing O&M expenses, the pipe may be far less than the cost of the treatment. So over the life of the facility, running the pipeline will be way cheaper. You want to have that in mind because you're the ones who are going to have to keep the facility running into the future, not the person who designed it. Another couple of considerations are energy efficiency and water efficiency. So do the alternatives have different impacts on energy use, energy efficiency, or water use, water efficiency, and how that might impact your choices? So if you're in a very water scarce area and one alternative uses less water than another, that might be really important to you. Or is one alternative using an alternative energy like renewable, something, you know, solar power versus another kind of energy. And then we want to think about whether we're just considering standard technologies or whether new technologies are being considered. And this can be good or bad. Sometimes when new technologies come into being, they're not tested well enough. We don't really know if they're going to work, and you may not want to be somebody who's trying that out. On the other hand, if there are technologies that have come on the market and they're showing real promise and they would work really well in your facility, you don't want to ignore them. So it's really just a chance to look at whether there's new technologies that might work, and if so, how they might work. Another thing to look at is the write-up of the alternatives. So typically you will get a report of the alternatives evaluation, and it might be part of a preliminary engineering report, it might be a standalone report, but you'll get some written information about the alternatives evaluation. You want to look at that write-up and see, what does it look like? Is there 15 pages about the chosen alternative and 3 sentences about all the others? So it looks like maybe they were not given equal weight. So if that's the case, you might need to push back and say, hey, look, I'd like some more information about some of these other alternatives because I'm not sure if they were all equally valued as potential options. Then you want to look at the costing portion, and kind of the same thing. Is the costing considering the life of the facility, and is the level of detail similar between different options so that you can tell that they were given equal weight? So a few examples, one water system that we worked with was, and we worked with them after this happened, they were given a reverse osmosis system, but it wasn't needed. So the alternative chosen for them was one in which reverse osmosis was used, and there really wasn't a contaminant in the water that they needed to take out. It ended up costing them not just the cost of the reverse osmosis and all of the expenses related to that, but a lot of other problems occurred. So they were having, because reverse osmosis creates some aggressive water, they were having problems in their pipelines, they were having trouble with lead and copper violations and that sort of thing, as well as rejecting about 25 or 30% of the water produced. So it was a really major situation for them, and it was not the right alternative for that system. And another system did an alternative, or had an alternatives evaluation process done, but it ignored cheaper, better alternatives and had to be rejected by the state revolving fund agency during its review because the alternatives evaluation was not done properly. You don't really want that to happen. In that case, they had to go back and the engineer had to redo it. It cost the system some money. So we really want to make sure that our alternatives evaluation process is done well. So in thinking about past projects that you've done, think about how involved you've been able to be in the alternatives evaluation process in the past. Have they asked you your opinions about other alternatives? Do you feel like you've been getting the best alternatives? Do you have any cases where you feel like a different alternative would be better? So it's really important to think about how that process has worked and how you might make improvements in the future. So remember, intervening during the design phase still allows you to exert a lot of influence at a relatively low cost. And the more you're involved at the design phase, the better chance you have of having a positive long-term impact and having this operations point work well for you. So even making a change at the 90% design level might be the best decision for you in the long term, even if it feels like you're kind of at the end and it's going to cost you some money to redesign. It's still better to do it now than once you put the facility in operation and you can't make any changes at that point. So moving along from the alternatives evaluation to the other part of working with engineers that I wanted to talk about today is that operations and design is a really important collaboration that often doesn't take place. So we really want to think about operations and design as a collaborative relationship. It's not an us and them, it's a we. If you have both of those, operations and design, you've got the best of all worlds, because designers are thinking about the initial, how do I make it work? What pieces need to be in place? Where the operations folks are thinking long term, how do I make this work for my customers into the future? So you want to think about whether or not your operations personnel get to be involved in design discussions. Who gets to be involved? What's the focus? At what point in the process does that occur? The earlier in the process that occurs, the better chance you can influence the project in a positive way at the least amount of cost to you. And if you do involve your operations, are your engineers listening to you? Are they speaking in a manner that you can understand? And don't be afraid to ask questions. Don't feel like you can't ask them to rephrase something or explain it in other terms to help you better understand what they're talking about. Because sometimes there's acronyms or terminology that makes sense to them but might not make sense to you. And if you get it explained in a different way, you can have a better conversation. And remember, you as a facility personnel know the specifics of your system better than anyone else. You've been running it for, 10 years, 20 years, 30 years, however many years. And while the engineer knows how to make water and wastewater treatment plants work and how to design something, they may or may not be well versed in the actual operational impacts of the design that they're creating. So their world is not the operations world, it's the design world. Your world is the operations but not design. So together, you will have the best of all worlds, because design and operations are intertwined and they can't be separated. The best design won't achieve its intended purpose without good operations, and likewise, the best operations will not fix a poor design. So we really want to think through operations as an integral part of design, because by the time you get to the operationals phase, you have the least influence at the highest cost, and that's very problematic. So when we think about including operations in design, some of the things we want to think about are what are the major activities required in the routine operation of each asset that's included in the design? What are the maintenance requirements? So thinking about once you get this facility given to you and you have to operate it, what are the things that you're going to have to do to operate it? So what spare parts will be required? Where might they be purchased? What is the cost? This might sound like something, why would I be concerned about that? But if you're not careful, you might get something designed for you or installed that has parts that need to be purchased in a very exclusive location. Like, for example, there was one utility that had a UV disinfection system given to them, and the spare parts had to come from Germany. It was exceedingly expensive for them to get the parts, and if a different unit had been used, they might have been able to purchase the parts in the United States or get them closer to where they were and spend a lot less money. So sometimes there may not be an option, like maybe you have to have that particular unit, but at least that should be considered. So is there another option, or what must I think about in my budget going forward if I'm going to have a facility that includes expensive spare parts? Also think about the level of certification that you're going to have. Is it going to be different from the one you had before? So are you getting a higher level of sophistication? So maybe you were a level 1 operation before, and now you're a level 2 or 3 or even 4 system where you're going to have somebody with higher level certification. If you're in a small remote town, it might be very difficult for you to get a higher level operator. Then you might want to think about, well, is there an alternative that doesn't require me to have that higher level of operator versus another one? So perhaps, when we talked about our example about arsenic, one of the options was to run a pipeline to another facility and get raw water, or get raw or treated water from them, so we wouldn't have to do arsenic treatment. Well, that alternative would probably keep you at a lower level facility operator certification wise, whereas if you install an arsenic treatment system, you might be moving up to a level 2 or 3 or 4 facility, which might be difficult for you. Would there be any level of specialized training required, like beyond what you normally do? So one example here is, what if you don't have SCADA now, but the new design includes a SCADA system, and that's the electronic operation of your facility. So in a SCADA system, there are electronic units out in the field that can transmit data back to a computer or a control area, so you can run your facility remotely. Well, if you never used SCADA before, you will need some specialized training in SCADA and how it works and how to maintain it so that you can run your facility properly in the future. And it's important to know that you might need that kind of training. And if that's going to be problematic, then perhaps SCADA is not right for you. Thinking about what number of operators will be required to operate the new facility and whether that's different than the existing facility. So one example here is a utility that operated just during the day, Monday through Friday. They were able to make enough water during that time to fill their storage tanks, and they could go with just daytime operation. They had a need to expand their facility, and the way it was done to keep the footprint of the plant smaller was to change the way the system worked. However, when they did that, they could not shut the system down the way they used to, so they needed to operate 24/7, 365. That meant there had to be multiple shifts of operators, 7 days a week, so obviously they would need more personnel in the future than in the past. So that's something to think about because the budget will be changing for them. It might still be the best alternative for them because otherwise they were going to have to purchase more property. Maybe that would have been problematic or possibly even impossible to do. So this might be the only alternative, but it's just something for you to consider because you will need to hire more people and your operations budget would increase. So here's an example of a case where blending operations and design would have resulted in a better scenario for a utility. So this is the original design of a pump that pumped water into a chlorine analyzer. So this pump is actually about a 0.5 horsepower pump, and it was greatly oversized for the application at hand, and it cost about $1,500 for the initial pump, and then every couple of years it had to be taken apart and rebuilt, and that was about another $900 every year or two to keep that running. What the operators figured out is they didn't really need a pump with that much horsepower, that heavy duty. They were really not going very far away. A tiny pump would be able to do it, and this particular pump that they ended up using is about $250, and it is not one that they have to repair. Whenever it stops working, they can just put a new one in, and it seems to last for a couple of years before it needs a new one. This one is just $250, so right away you can see the cost differential between the initial pump and the one after the fact. So, you know, if you work together, you can kind of address these problems before they occur, because if you look at the pump on the prior picture, yes, that pump worked. So from an engineering standpoint, that was okay. But from an operations standpoint, it created headaches because they had to spend a lot of money rebuilding the pump every couple of years, and it was really more than the operations required. So the more you can blend the two together, the better projects you can have. Another example is a utility that made a change during design. They had a water treatment plant, and it had a control room that was designed to be kind of off to the side and just a regular room with, you know, walls and a small window. And the operator said, well, if I turn on a valve or I start the filters, I can't watch what's happening from here. I'm going to have to leave the control room, walk over to the filter, see what happens, and then go back. And I would much rather see what's happening right as I'm pushing the buttons so that we know everything is working fine. So in this particular case, the operator suggested, why don't we create a glass control room and move it to the middle of the facility, and that way we can see what's going on as we're operating, and we'll be right there watching the filters, and we can see everything that's going on in the plant. They went ahead and made that change, and it was a very positive change for the utility. It probably cost them a little bit of money, but over the long haul, it will save them quite a bit and make the operations process work better. If they would have waited till later and said, oh, we don't want the room here once it's built, we want to build a glass enclosure, imagine the retrofit cost of doing something like that. So again, it's important to address these concerns as soon in the process as you can to have the least cost and the most influence. So it's important to remember that a whole project is both capital and operations. So that initial, building of assets and the operations over the lifetime. So we want the whole story, which requires both design and operation. And after the project is constructed, you're going to have to operate it for the next 25, 50, 75, who knows how many years those particular assets will last. You have to be able to do that, and you want to make sure you're prepared for that. So we really do want to think about the project over its entire life to make sure we're not just basing our decisions on the initial construction costs, but we're basing them on all of our costs. Now let's move on to a different part of the grants management process, and this is looking at milestones. So once you're ready to do a project, it's a good idea to set some milestones. These are the major and minor tasks along the way to completing the project. So the first step is to pick our major boundaries. So our project initiation and our project completion. So those are going to set the boundaries of our project. And then we want to think about what are the activities, outputs, and outcomes associated with these boundary conditions. So let's talk for a minute about what outputs and outcomes are. So outputs are what is created. These are numeric results. And these typically don't involve a consideration of quality. They're thinking about quantity, so how much. So some examples: the number of people served by a water system, the number of gallons of water produced, the number of miles of pipe put in the ground. So in these cases, we're not talking about, let's look at the last example, the number of miles of pipe put in the ground. We're not talking about whether they used the right material, whether that was a quality installation, whether the pipe's any good. We're only looking at, do we have 10 miles of the pipe in the ground now versus later? We put 2 miles of pipe in. It's strictly a numeric thing. When we move on to outcomes, now we're looking at the level of performance, achievement, quality that occurred because of what you did. So this is an assessment of the success of the project. What were we expecting to have happen? How do we expect things to change because of what we did? So some examples: the increase in the percentage of the population served by water meeting EPA's primary drinking water standards, reduction of a particular contaminant in the drinking water, such as arsenic concentration going down, like we've been talking about. And outputs and outcomes are both needed to assess a project. It's not that one is important and the other isn't. We want both of them to really tell us what's going on. Outputs are usually easier to measure and faster to achieve, and outcomes take longer to see but may better define the overall success of the project. So if we put both together, we'll have a really good idea of how well run our projects are. So building projects to achieve these outcomes involves looking at the outcomes you're trying to achieve. So why are you doing the project at all? And if you can't answer this question, you shouldn't really be doing the project. So this is something you should be able to answer for yourself. Why am I doing this? So what is it I hope to achieve? So I hope to have more people in compliance, or more people served, or replace pipe that's very problematic and been breaking a lot. You should be able to describe the general outcome you're trying to achieve with the project. Then you want to turn the outcome you want to achieve into something that can be measured. So thinking about it in a way that you can collect data and determine if you met that or not. You want to confirm that the outcomes are linked to the outputs and activities that you're going to do along the way, and whether or not you're going to get those outcomes based on what you're actually doing. So if you say, my outcome is better compliance, but you're not doing any project that addresses compliance, you're not going to achieve that outcome. You want to implement the measurement of outcome and track achievements so you can tell funding agencies, regulatory agencies, elected leaders, and customers what you've actually done. So you want to determine what the expected outcomes and outputs are of project completion, and then think about the activities you need to achieve those outcomes and outputs. You want to place the major activities needed to achieve these outputs and outcomes on your milestone graph. And then you want to put any minor activities in between those. So what's going to take place between your major activities? And then you want to look at, do I have enough activities to really define all the major things I'm going to do? And if the answer is no, you can always add some more. And once all the major and minor activities are included on the graph, you can add a schedule. So For example, in this example, we're going to initiate the project in May of 2019, and we're going to end it September of 2022. Then we can work with our engineers, our funders, others to try to put the rest of the dates in there. So when do we expect each major and minor activity to be concluded? Next, we want to look at our project costs. So what is our total project cost? And what are our anticipated costs for each particular item along the way? So we can create a table that includes the major and minor activities, including our completion date and costs. And then we can look at how our expenditures are spread out over time. Do we have long periods with no expenditures? Are costs higher up front, the middle, at the end? We generally think of ramping up the costs at the beginning as construction activities, design activities take place, and then ramping down at the end as the project is slowing down and we're getting near completion. If there are long periods with no expenditures anticipated, you might want to add some minor tasks to spread out those expenditures and allow you more opportunities to check on things. And then during the project, you want to check your actual activities, your schedules, your expenditures against the ones you had planned. So you want to look for places where the actuals don't match your anticipated. So where was the schedule going off course? Were there problems where we were not meeting the schedule? What could we do to get back on schedule? Would that slip change our costs in any way? Might this cause us any regulatory compliance problems? So really looking at that schedule and what caused it and what you can do about it. And you also want to track your actual costs against your anticipated costs. So what did I think would happen originally and what actually happened? So if our expenses are over the anticipated costs, what are the reasons for the over expenditure? Is there any way we can get the project back on track? Is there an impact on the ability to get the project completed at all? How are over expenditures addressed? Like what's going to actually happen? Where will the extra money come from? Can I go back to the funder? Must I take it out of my reserve funds? Must the community use its funds? You know, how are we going to address that issue? If the expenses are less than anticipated, what can be done with the extra funds? Sometimes you might be able to do additional work. Sometimes you'll have to return the money. It kind of depends on the particular funder and the type of funding you got, what you might do with money if you have some additional funds left. And then during the project, you want to consider whether the anticipated outputs and outcomes are being achieved. Is the project able to meet the desired outputs and outcomes? And if not, which ones won't be achieved and what are you going to do about it? Is that going to be problematic if you can't achieve all the outcomes? And if yes, the ability to meet these outcomes, you want to measure that so that you can tell people about what you've done and how you've done it. You also want to consider whether problems with budget or schedule could have an impact on your ability to meet your outputs and outcomes. So finally, let's finish up talking a little bit about finance. And the three things we'll touch on are accounting, bookkeeping, and reporting. So accounting is sort of that overarching term that covers all the financial things that you're going to do in your facility. It's concerned with getting timely and accurate recording of transactions, providing useful information, and providing reporting for various people's needs, including funders. When we get to bookkeeping, this is where we're actually keeping track of income and expenses, and we're trying to make sure that we have as much money coming in as going out, and hopefully our revenues are greater than our expenses, and the goal of bookkeeping is to try to make sure that happens, and we want to collect the necessary financial information to file the required reports that we have. Then we have, the bookkeeping actually refers to the actual transactional entering of this data, so writing checks, processing payroll, that sort of thing. Reporting is when we're actually taking the information in our accounting and bookkeeping processes and creating reports for internal and external purposes. So internal reports might be used by governing bodies, management, other people to see what's going on and to make changes. And external reporting can be used by individuals outside the organization, such as your funders. So the financial process involves identifying and recording transactions, reconciling and analyzing accounts, summarizing into monthly or quarterly reports, doing a year-end audit, that might be a certified public accountant audit, or it might just be internal, depending on the size of your facility and the requirements you might have. And then you repeat that process, because this is something that goes on continuously. So a word about cost sharing and matching paperwork. So some projects require you to do a match. Sometimes it's just a voluntary thing that you might do, and some projects don't require this at all and you won't have a match. But this is the portion of the project that a recipient contributes. So somebody might say, well, I'll give you 95% of the money and you have to match it 5%. So then you either have to come up with cash or an in-kind match, you know, based on people putting in free time to help you. But you must document the match, whether it is in kind or money, and it must be documented in the same manner as your other costs. So progress reports, just about every, if not every EPA project has some kind of progress reporting requirement, and many other agencies do as well. It might be monthly, quarterly, or semi-annually, or even annually. You want to check to see the requirements for your grant and what the due date is. Oftentimes it's 30 days following the end of the period you're reporting on. And then establishing a means of alerting you the report is due. So we want to try to develop an easy way to do reports, so don't wait too long for documentation. So example, have a set place where you write down anything you did during the week, and have a standard format so it's easier to create the report. Spending grant funds. You want to comply with internal and external regulations, policies, and procedures. Consider the audit readiness of every transaction you do, and review expenditures versus budget on every transaction. You don't want to have any supplanting or cost shifting, meaning you're using this grant money for purposes for which it was not intended. Think about how you become aware of specific requirements of the grant and whether or not you have a checklist or some other process to keep abreast of the requirements. Think about how you save your documents, whether they're electronic or paper. You want to make sure you have multiple places where you can store your documents, whether that is electronic or paper, and don't put everything all in one location. So having it on two computers won't help you if both computers are in the same building. So if you have a fire, a flood, a theft, you might lose all of your records. So make sure that one set of stuff is somewhere else, in the cloud or in an offsite location, so that you won't lose everything. There are regulations that govern how grants are managed, how payments are made, that type of thing. Know those regulations before your project starts so that you can make sure you comply with them. And know the specific reporting requirements that you have and follow those throughout the project period. So in summary, we want to think about the fact that where we intervene in the process will have a big impact on how much it costs and how much influence we have. And the earlier we intervene, say in planning, will help us quite a bit because it'll be a lot easier to have an influence at a lower cost. We want to think about working with our engineers, in particular the alternatives evaluation and involving operations in the process. We want to think about milestones, outputs, and outcomes. And finally, the financial records that we need to keep and how we need to keep them and what reporting we have to do. Most funders will require you to have quite a bit of reporting. They'll have a format that you need to follow so that they can be assured you're spending their money in the right way. So with that, I think we have a few minutes to have a couple of questions. If you have any questions, please write them in the chat box, and then Tess can read them out and we can cover some questions. So Tess, have we had any questions come in?
Yep, we definitely have a few questions, and we'll give you, some more time. If it's still in your head, you can type it out. We'll get to it, hopefully. The first question we have, this is kind of going back to earlier in the webinar, and I believe you did answer this, Heather, but it is important, so it could bear some repeating. But what are some typical examples of O&M expenses, and what types of projects might go along with a significant change or frequency in those types of activities?
That's a really important question, and I think we did talk about that, but we'll talk about it some more because that is really, really important. So what we need to know is, what would an operator have to do now? Like, where do they have to go to, say, start up the treatment plant? So right now, maybe they have to go to a pump station or a treatment building, turn valves, you know, open switches, etc. Maybe in the future, it's a SCADA system where they sit in a room and they push buttons. That operation and maintenance would be very different. Thinking about the maintenance of, let's say we do a solar panel instead of plugging our pump into an electric outlet. That might change the requirements that you have energy-wise and how you maintain the solar panel versus the general electricity. Looking at treatment units, and so let's go back to our example about arsenic. Well, one type of arsenic treatment is an absorption system. So it's basically a big vessel with some media in it, and the water passes through the media and the arsenic gets absorbed. Over time, you have to take that media out, you have to dispose of it and put new media in. If you were not using that type of system before, you would not have those operation and maintenance requirements. But in the future, you would need to know that, you know, in some cases that replacement might be $20,000 or $30,000 every time you do it, and it could happen once a year, twice a year, once every couple of years, and that's a big expense that you need to know for the future. And at the beginning, when people were first looking at these arsenic facilities, many of them thought it would last 3 or 4 years, and they were finding it would last 3 or 4 months. So those O&M requirements are really important to remember. So the best way is to really look at the design and go through each portion of it and say, okay, you've designed this pump station. What would be required to maintain that pump station? What will we have to do to the pumps? What will we have to do with the electrical components, the motors, etc.? You know, is there any lubrication that has to be done? How is that done? So that you can kind of start getting an idea of each step of the way, what the O&M requirements are, and then compare that to what you do now to know if you're going to have a higher budget or more people or more training or something of that nature.
Great. And switching gears a little bit, so with any type of grant-funded project for a water system, it often is going to involve an engineer, or a good engineer, hopefully. So what advice do you have for selecting a good engineer for one of these projects?
So I think there's what you want to think about there is, what are you looking for in your engineer? So you're looking for somebody who is willing to work with you. So asking them questions about how they'll involve your staff. How involved can your operations people be? When are they going to work? You know, when are they going to meet with you? Are you only going to see them at the 30%, 60 and 90, and then they're going to go away in between? Are they willing to work with you in the middle? Finding out the experiences they've had on similar types of projects. So are they used to working with a system of your size and type? So if you have an engineer who typically works with very large communities in your small community, you might want to check to see if they're well versed in small community issues, so that they understand what issues you might be facing and how those might be different from a large system. So you're trying to find out if the engineer has experience with the type of work you want to do and how willing they are to be a collaborator with you. So you don't want somebody who's not willing to be a collaborator. You want somebody who is very willing to work with you and make sure that you are a collaborative partner and it's not an us and them relationship. And you can always ask other people who worked with the engineers to, you know, what was your relationship like? How did they treat you? You know, did this work out well for you? So that you can get information that way to pick an engineer that will work well for you.
Great. And I think we have time for one more question. You talked a lot about reevaluating these projects if they're not the right one. So in an example, you know, for example, if you were to reevaluate and figure out that maybe you needed or had different goals or were hoping to achieve different outcomes, what's a good approach for dealing with that funder and maybe getting a different type of project accomplished than what you originally set out to do?
The best case scenario in that situation is to go immediately to the funder and sit down and talk to them face to face as much as possible and say, hey, look, we thought the project was going to go this way. And after we reevaluated, it turns out that it would be way better if we do it another way and really sit down and talk to them in a very, very collegial, cordial way. This is not an adversarial thing. This is a let's help each other, because they don't want you to spend their money inefficiently either. So you both share the same goal. And so maybe that will require you to submit some additional paperwork. Maybe you have to redo some things, but really sit down with those funders, explain the situation, and try to see if you can't adjust the project to make it a more efficient, effective project. Because one example I have is a community that it was a wastewater situation. They thought they were going to use a particular process at the beginning. They went forward with funding and everything else with that in mind. It turned out that they could do a different process that would work a lot better. And initially there was some pushback that no, you can't change anything. But when they were able to bring forward their goals, why they wanted to do it, the cost savings that was going to occur both initially and over the life of the project, it was going to save considerable energy usage over time and considerable operation and maintenance over time, and it was going to save up front about $1 million of construction costs. So when they were able to go forward and talk to the folks, they were able to make that change. So I think it's really important to sit down with the funders and explain the situation and why it would be beneficial to move forward in a different direction. Because most of the time, everybody's on the same page that they want efficient, effective projects that are going to meet the goals.
Awesome. Well, I think that's about all we have time for. If there's any remaining questions, feel free to send them to smallsystems@syr.edu or any of the other communications you've had, or back in the chat box even now, and we will follow up with you. I have one last polling question. Like we discussed in the beginning, the Environmental Finance Center Network does a lot of small systems technical assistance, and we can even assist you on a grants related issue. So feel free to let us know here if you'd like us to get in touch about technical assistance. We are able to set you up with an expert that can help in most situations. So I'm going to give you just another second or two to respond. And then Heather, I will toss it back to you to close out for today.
Well, I just want to thank everybody for being on the webinar today. We really appreciate your interest in this topic. And if you have questions after the webinar is over, you can always email them, and we will be happy to answer them. I wish you luck with all your projects, getting grants or loans for what you need to do, and then developing a good project at the end. So thank you again for being with us today, and have a great day.